Hello students, today in this video we are going to study about the complex numbers first. So our success criteria is to use the Argan plane to represent the rectangular form of complex numbers. Now first of all understand that what are the complex numbers. So let's see an example. First of all, think that what complex numbers are. Now, you can understand this concept if you understand that what real numbers are. So, if you remember that all the numbers that exist in the world or in the universe are said to be the real numbers, which means that whatever you imagine the number, for example, 0 is a number, so it is a real number. Even if you say that there is a number like half. Okay, so it is a fraction, but it is also a real number. Similarly, let's suppose there is a number 6, it is a real number. There is a number 0, it's a real number. Number half, which is in fraction, it is a real number. 0.75, it consists of a decimal, but it is a real number. Similarly, there are some universal numbers and on which a lot of research had been made, that is pi. Let's suppose, so the pi, it is 3.14. So this is also a real number. It can also be written in the form of 22/7. This is also a real number. Even if we write the numbers with a negative sign, they are also a real numbers. Now, there are some numbers which are the imaginary numbers. Now, the mathematicians have made or have worked on the imaginary numbers to prove some or to make some inventions be happened. Okay, to do some inventions, they just imagine few of the numbers so that they can find their required results. Now, if we write a number in the form of let's suppose the x, that means the real part, real numbers, and also we write with this any imaginary number, so they are said to be complex numbers, which means that complex numbers are the numbers that contains the real part and the imaginary part. But in order to represent the imaginary part, you have to write the I. So this I represents the imaginary part. So now I am just representing by the variable x plus yi, and in some of the books it is written in the form of a plus bi. And altogether this expression can be written as equals to z. So this is a form of complex number. Z equals to a plus bi, or some people are writing, or in some of the books it is written in the form of x plus yi or iy. So x, the number which doesn't contains the I, is the real number, and the number that contain I is the imaginary number. Now let's see some examples. For example, z equals to, write any number, for example 4, and write an imaginary number, let's suppose 2. So when I write the imaginary 2, then I have to write I also. So now the 4 is the real number and 2i is the imaginary number. Let's think one more number which contains the real part and the imaginary part. The numbers can be negative also, can be in the fraction also, and could be anything. So let's suppose I try to make it negative 0.1 and negative, for example, 1/2 or half and I. So this is also a complex number. The reason is that it contains the real part and also an imaginary part. Now the question comes that for your understanding, we can denote the complex number in the form of a plus bi, whereas a are the real numbers, and real numbers can be rational number, can be integers, can be whole number, can be natural number, anything. Okay, even if I am writing here 2 and 2, it can be made complex number by thinking that the imaginary number is 0. Okay, so 0i, anything multiplied by 0 is 0. So this is also a kind of complex numbers. And imaginary numbers can be the same numbers, but they has to be denoted with the I. So here we have understood like that the complex number can be shown as z equals to a plus bi, whereas a is the real part and b is the imaginary part. Now what is I actually? What the mathematicians had in their mind that they wrote I. You know that the square root of any negative number is not possible. So if you write, for example, -1 in the calculator with the square root, so you would get the error, which means that the function is undefined. Okay, so that the number is undefined. You don't have any answer for the negative one. So in some of the calculations, mathematicians had thought that square root of -1 can be denoted by the I. So if I is square root of 1, -1, so this is I. So what is I square? If we multiply this by -1, what would happen? According to the mathematical rule, square root and square root would be cancelled and this will give us -1. Or in other words, if I want to find out the I square, so I can write it as -1, square root of -1 whole square. And we know that the value of square root is half. So half times 2, it will gives you 1. So you will be left as -1. So by using the algebraic properties, we can say that I square is equals to -1. Now the question comes that how can we denote this complex number on the argand plane? Now what is argand plane? Argand plane is a coordinate plane that consists of the real numbers on the horizontal line, that means on the x-axis. So on right hand side you have all the positive real numbers, and on left hand side you have all negative real numbers, like real numbers 1, 2, 3 and 4 and so on. And on the left hand side, -1, -2 and so on. And what about the y-axis? So on the y-axis, all the imaginary numbers are written. So above the x-axis, all the positive imaginary numbers are written, and below the x-axis, all the imaginary numbers with the negative sign are written. So you can say -i, -2i, -3i on the y-axis, and at the bottom you will have +2i, +i, +3i on above the x-axis, and -i, -2i would be below the x-axis. So this is how we represent our argand plane. So what is argand plane? Argand plane, it is a coordinate plane on which the real and the imaginary parts are shown. Real numbers are shown on the x-axis, whereas the imaginary numbers are shown on the y-axis. Now, the thing is that how can we draw, or how can we show the complex numbers on the argand plane? So here in front of you, you can see an argand plane. So on x-axis, you would find all the real numbers. So for example, this is 1, 2, 3, 4, 5 and so on. On the left hand side, you will have -1, -2, -3, -4 and -5 and so on. And on the y-axis, we will start from I, 2i, 3i, 4i and 5i and so on. Similarly, at the bottom, okay, below the x-axis, we will have -i, -2i, -3i, -4i and -5i. Now let's draw the number. So this is very easy. However, how we already know how to graph the numbers containing the x and the y axis. Okay, that we have learned in grade 7, I guess. So same way we will draw here, or we will sketch, or we will indicate our complex number here. So here 4. So 4 is the real part. 3i, because it is I, so this is the imaginary part. So the real part you will see on the x-axis, and the imaginary part you will see on the y-axis. Now have a look how can we sketch the graph. So 4 you can see here, this is the 4, okay, on the real part, and 3i on the x-axis, that is here, 3i on the top on the y-axis. So you go up 4 and 3i, just sketch it here. So this is how we show our rectangular form of a complex number. Now if they only ask you to just show the complex number, then only just make a dot. And if they ask you to show the direction also, so just join it with your 0. That means with the origin. So that's all. Let's see one more question. -5 plus 2i. So -5 is the x-axis, is the x part on the left hand side, and 2i is our imaginary part which is above the x-axis because it is over here 2i. So -5 and 2i just go up. Where is, I will show you, this is 2i, this is -5. So we want only this point. So once we draw this point, please erase all these lines. That's all. This is how we do, and you can also connect it with the origin if they ask you to show the direction also. Here same, 6 minus 3i. So how can we draw? The 6 is the real part, and -3i is the imaginary part. Now 6 on the right hand side here, it is the 6 on the x-axis, and -3i is here, -1, -2, -3i over here. Now sketch the graph. So go on the 6 down, yani go down, and -3i horizontally, and your answer will be over here. So the point which I am showing is here, and you can just connect it with the origin. -3, -i. Let's draw this one. So -3, it is the real part, and -i means actually -1i, right? So this is our imaginary part. -3 on the left hand side of the axis, so this is our -3, and -i, it is below the x-axis, that is the first box, -i. Now try to sketch the graph, go down and come on this side. So this is the point we have connected with the origin. So this is our answer. I hope that the concept is understood to you. So if everything is understood, let's draw it. Now here they are giving you a lot of complex numbers. So take your time, pause the video, do the questions yourself, and afterwards, after 2 minutes or 3 minutes, check with my answers. So here are the answers. So first of all, it is better that if we name them. For example, the first complex number is A, second is B, denote the third one with the C, fourth one with the D, fifth with the E, and sixth with the F. Now let's try to sketch it. -3 plus 2i. Okay, so -3 on the left hand side, and here you have the 2i, and here we have -3. Go up, this is our first point. Draw it or sketch it or represent it with the form of A. Now 1 minus 3i. So 1 is here, and 3i, it is on the top here. Go up and just draw this one. This is our B point. The third is -4, -i. -i means -1i, right? So here it is -i, -2i here, for example, and -4 on the left hand side over here. So we are going on the -4, -i. Here is our point. So represent it with the C. Now D is 2 plus 3i. So here it is 2 and 3i is on the top. So go up and this is the 3i. So just sketch it, name it as D. Now what about the 3i? Now in the fifth part, when 3i it is given, so it means that the real part is 0 and the imaginary part is 3i. So here 3i is only on the y-axis because the x is 0 on the y-axis. So 3i, it is going to be here on this part. So name it as E. Now -2. Last part, -2. Now -2 means the real part is given to you and the imaginary part is 0. Which means that you have to sketch or you have to show it on the x-axis. So where is -2? So this is our -2. So just on the x-axis plot it, name it as F. That's all. So this is how we sketch or we represent the complex number on the Argan plane by showing only by showing only the real and the imaginary part with the help of a dot. So take your time and see that what is the answer. 3 minus 4i. So let's see here 3 minus 4i. Which one is correct? 3 minus 4i. 1, 2, 3 is here and 1, 2, 3, 4. This is -4i and here it is your 3. Okay, so is it on the correct part? No. So let's check where is the correct part. Okay, so on the third one, it is, they are not actually sketching 3, -4, right? They are sketching 1, 2, 3. So 3 is correct and 1, 2, 3, 4. They are actually not sketching 3, -4. They are sketching 3 and 4. So this is also not our answer. Now check the D part. Now D part, what they are sketching 1, 2, 3. So this is -3 and 4. Okay. So on the fourth part, they are sketching 1, 2, 3 and 4. So they are actually sketching 3 and 4, not 3 and -4. Now let's see the third part, C part. So 1, 2, 3, it is here and -4, 1, -i, -2i, -3i and -4i, it is here. So yes, this is our answer. So C is our actual answer. Now try to compose a complex number. Write a complex number from yourself. Write any complex number which comes in your head containing a real part and also an imaginary part. And after it, write it in the rectangular form, that is a plus bi form. You have to write it, okay, and represent it with the help of Z. So this is what you are thinking. So after that, tell us where is the real part. For example, this one is the real part. Where is the imaginary part? So you have to show that which one is imaginary part, means label them. After that, plot it on the Argand plane. So let's suppose my Z is -1 plus 4i. For example, this is coming in my head. I made my numbers myself, and now I have to show that this is my real part and this is my imaginary part. Means real part is -1 and imaginary part is only 4. I means imaginary, so only just show the numbers. After that, plot it. So -1 here and 4, 1, 2, 3, 4. So this is over here. So just write on the top -1, comma and 4, and this is how you have to do this work. But this is my work, so just do your own work over here. I hope that you understood the concept, how to convert, how to write any complex number and how to draw or sketch the complex number on the Argand plane. Now practice yourself and see you in the next video.